where we are right now is that if you have a job that is, remote, doable remotely, which at this point is most laptop jobs, right?
The computers,
most white-collar jobs.
Maybe get better at that.
Yeah, it feels really achievable that we're going to be able to get there.
This is very unintuitive because forever technology replaced blue-collar work, but now technology is replacing the bureaucrats, and the blue-collar like plumbers are like, we're fine. But
yeah,
the annoying lawyer people are like, they're in trouble.
I mean, the thing right now is what we're seeing is that technology is basically eliminating the rote parts of the jobs. Right. So when I used to program, I remember I would, have to write all these like XML configs. And nowadays, you just ask, GPT-4 and it'll write the XML configs for you. But you want to do something really interesting, then, you need to bring your human intelligence to the problem, even if it's just telling the model, how to go about it.
So you're closer to this than 99.999% of people in the world. So I want to ask your intuition, because I've talked to Sam, obviously, who's involved in this. And I think you may even be more technical than him and you're really close to the research. So, the next 10, 20 years, like what else are you are you just gonna be able to do everything people can do in 5 or 10 years? Is this like a total change in all of reality by the 2030s? Are there actually a lot more steps potentially still? Like what's gonna happen here?
Yeah, I mean, the thing about AGI, artificial general intelligence, which is people call AGI, is that it's very clear to me, and I think it's clear to people who are working in the field, that progress is going to continue to happen. What's hard to predict is when you actually are able to do a particular job. When there's so many different things that are wrapped up in any particular job, that it may turn out that something we didn't even expect was the last thing that needed to be automated. So I think we're going to have a long time.
We may not have like perfectly realistic Westworld robots walking around in like 7 or 8 years.
For robotics, we're probably going to need AI to write that, to figure out how to build robots for us.
But I mean, you're going to that's the other question is, I don't know what's public or not, so push back on me. But like, the thing I've heard from various people is you could probably do GPT-5 and 6 and maybe 7 with people. And then at some point you're going to need to get to 8 or 9 or whatever. You're going to need GPT itself to do that. If I was running a research group, I'd already be trying to probably figure out how to get this thing to teach itself in different ways. That's probably there's lots of concepts there, I'd imagine, that you're trying to figure out. Like how far are we away from it teaching itself? And is that a thing you guys are working on that you could say?
Yeah, I mean, I think that's what I think that's sort of the open problem that everybody sees right now, is that, the current, as you say, the current GPTs are all just mimicking what humans do. So how do you unlock creativity, right? And if you think about it, it's that same problem we had with Dota or with games, where because you have this structured environment of a game,
it was able to be creative within the structured environment by trying
right.
new things. So how do you give it the ability to be creative within the structured environment of reality?
And that we don't know. And I think the interesting thing even now is just how do you build a structure of reality for the agent to play in?
That's interesting. I mean, I imagine you already have lots of versions of 3D structures of reality, obviously, for robotics to play in, but I guess it's more complicated to have a structure of like human reality.
I think the most interesting structure we have now is actually the compiler, the interpreter, and being able to write code, run code, see what happens.
Interesting. So that's actually a more dynamic place for them to live, is like learning how to write code and iterating on what happens with code it writes.
Yeah, I actually spent a lot of time at OpenAI thinking about 3D worlds, and ultimately the problem with the 3D world is it's very limited because you have to create everything interesting that's in there.
That's fair. Right? There's no. I guess you could create a bunch of like human and emotional actors or something like this for it to interact with, but you're going to create some really dorky robots. They're all just going to be really good coders.
But hey, you know what? You can you can be all the non-dorkiness. Humans can bring the non-dorkiness, well, and
I will not be able to bring that, but normal people will be able to bring that for you. It's almost like you kind of need more human data. Like you need more data about how people just do normal human things and how they're feeling and how they're thinking, right? Because that's what we're missing.
Well, it's unclear. The funny thing is, there's actually a ton of if you just think about the internet, it is so huge. There's so much. And so there is a lot of data out there about how, if you think about a math problem, like how to approach the math problem, how to iterate on it, how to work with it. And then the other thing that we've done and that other companies have done in the last couple of years is hire humans to give us data. So, you start by training these models like GPT-4 on the internet. And there's this finishing step that you do, which is called reinforcement learning from human feedback, or RLHF. Mm-hmm. Reinforcement learning, it's like Pavlov's dogs. You give it a treat if it does the right thing. And human feedback means that you have humans who are doing it.
Yeah.
And so they'll have it, try to solve a problem. And if it has a good approach to solving a problem, then they'll say, great, you had a great approach. Whether it got the right answer or not, that turns out to be really helpful. And just do this over and over again. And you don't have a ton of data compared to what you pre-trained on.
One thing that's been unintuitive to a lot of us, we haven't caught up on any of this, is just that you think it would get better and better over time, but a lot of people seem to experience it getting worse over time, at least their latest interactions. Are they correct that somehow some parts of it seem to be getting worse over time, or do you have any thoughts on that?
We think it's actually getting better over time. That some of the reports are sort of confounding various different things.
So people are just confused about it.
I think people are just confused about this.
Because even really smart friends of mine who are close to me feel like it's not answering them as well as it was. But maybe they just got expectations too high or got confused on that somehow, huh?
Well, I mean, the models are stochastic. So, it's definitely going to be the case the answer you remember is the one when it got it right. And it doesn't display that flash of brilliance all the time.
And what's your intuition that you could say obviously GPT-3 was just fundamentally different than 2, and 4 is much better than 3. Like, are we getting to an asymptote here with your work? Is 5 just like way better than 4? Like, how are you feeling about this?
The way I think about it is that we are still pretty far away from the level of scale that is the human brain. Mm-hmm. And so there's no reason for there to be an asymptote. I think it just keeps working.
When you say level of scale, what's the intuition for that? Like, what's the scale of 3 or 4 versus 5 or 6?
Yeah, so you can count the number of neurons. And, this, again, like I said, this is very rough because a computer neuron and a brain neuron are not at all the same thing. There's probably an order of, it takes, 10 or 100 neurons to simulate a neuron in the brain. But, if you look at something like GPT-3, you can say, oh, well, that's maybe a lizard number of neurons. And GPT-4 is like maybe a cat. And you still have many orders of magnitude to go before you get to something that is actually the same size as a human.
Is that really relevant, though? Because, you'd say this is human. You say this is a blue whale, and it's like a lot more. And blue whales aren't, I assume, they're not much smarter than us.
Yeah, we don't know, actually.
I guess we don't know. They could be doing really cool philosophy in the ocean that we don't know about.
But, I think the other thing is that if you think about the data a blue whale is trained on, it's trained on, where are the fish, when does it open its mouth, and, when does it swallow? And,
it's not
we're training on the human data. Right.
So you want something the size of the human brain trained on the human data. So you still think it gets a lot better the next 3, 4, 5 years. Like we're on a curve right now. Like the world, it makes sense for forever to work on AI because it's going to be so much more important in 3 years. So that's your
I don't see any reason for it to stop.
So there's no number of years in which it would start to asymptote intuitively to you.
Well, look, I don't think I can put a number of years on it, but I think when you pass human level intelligence, that's where it gets kind of crazy in lots of different ways. Maybe learning by mimicking humans no longer works. Maybe there's an asymptote there. Maybe we have to switch to one of these other techniques.
Maybe you'll finally feel understood by a creature that exists. The way I sleep at night on this is I assume that there must be like multiple different S's. So like everyone always assumes there's like an exponential that just goes to the moon and the world's over, in a singularity. And I always assume there's like this and then another S and then another S. Is it possible there's like different paradigms we have to figure out that could take a while? Or do you think you guys have it all figured out enough to go all the way?
I think there really are. I think these things are fractal, right? And so in some sense, the paradigm is neural networks. But in another sense, you needed to figure out transformers.
Yep.
And so each of these S curves, that this is the thing that genuinely happens. Each one is some new way of making sure that you can fit more compute and more data into a larger network. And every time you sort of see a peaking, you need to have some sort of breakthrough. But it's not as fundamental a breakthrough as it was before. Like the difference between neural networks and linear regression was really big. And the difference between neural networks now and neural networks 2 years ago is just a series of tricks.